Hello, welcome back to part 4 of my evolutionary steering something food and poison system thingy. Now guess what? This creature here has violated the laws of my universe. And in the chat, I don't remember who it was that I could give credit to. Somebody pointed it out. Thank you, somebody. With a YouTube name, I apologize. Keep better track of that. Somebody will tell me who was who first pointed this out. Now, it's violating the laws of the universe. It could just wander across a piece of poison and not even eat it. Now, why is that? There's a couple reasons why. There's really one reason why. But look at this. Remember when I was like, oh, I'm going to let them have a perception radius all the way down to 0? Well, what if its perception radius was like 0.000001 or even was 0? Then it can never even see the poison. And it actually will only eat the poison if it can see it. Now there's one thing, my perception radius, my desire was that for that perception radius to only be something that it occurs to either be attracted or repelled to it. But if it wanders across the poison by accident, it should still eat it. And same for the food, honestly. It should get to eat the food whether it should perceive it or not. So one thing I should really do here, I really should have this checking to eat be a separate check. I do have this distance here, so I could check it whether it's like the closest or not. Like I really should just check it here. It should eat it, whether it's attracted or not. Let's do that. So I'm going to just take this. I could also just make a minimum perception radius, but I feel like doing it this other way for some reason. Like I'm just going to check right here. Like, hey, right before I check if it's something it should be attracted to, because eating and being attracted to are different things. Like I cannot be attracted to it, but I can walk across it and I've eaten it, I suppose. In the way that I'm thinking about this world. So I'm going to say if the distance is less than 5, I'm going to eat that thing. And it doesn't even matter if there's like 3 in a row. I'm just going to eat it, whether I'm attracted to it or not. So I'm going to do that. And then also, I really should be more thoughtful about this number 5. Do you know what would make sense? Is this, look at that. Its maximum speed is 5, but this actually makes sense because if it can go 5 pixels at a time, anytime it's within that maximum speed, it's not going to be able to jump over it. So I'm going to use that, just in case I change the maximum speed later, I'm going to just change that to this.max speed. And then I've got that same problem. If I'm removing stuff while I'm iterating through it, I should really iterate through that list backwards. So I'm going to put this here, length -1. I'm going to say go all the way down to 0. And instead of going up while iterating, minus. Now let's just see if everything works the same. Error. So what did I do? Cannot read property copy of undefined, seek line 81. So this is a problem. Maybe what I should do, so if it eats it, and that happened to be the closest one, it's not there anymore. So it also, if it's eating it, it doesn't count as something it's attracted to anymore. Okay? So it can't eat something and also be attracted to it. So again, probably this could be refactored yet again, but still a problem. Okay, so part 4 was supposed to be about the evolutionary stuff, but now I'm just debugging problems, and I realize this is not going to work. Oh boy, you got to really watch out for, maybe I should start part 4 over. No, I'm here. This is what's happening. You're watching this, you're still here. This is no good, because remember, I'm saving something that's the closest, and then I'm going backwards through the array. If I take something out, stuff moves around the array, and I save the closest index, which is no longer the index anymore. Here's the thing, though. I can fix this. I don't need to delete it down here. So I don't need to save the closest index. What I want to do is actually save that closest location. So closest is actually list index I. So I needed to save the I because I was removing it later, but now that I'm removing it here, I just want to save that particular location. It doesn't matter if the array shifts around, and now I can just seek the closest. So I'm pretty sure now, if closest is not null, right? Now I need to check not if the index is valid, but if it's not null. There we go. So now I should no longer be able to have something that violates the laws of this universe. Everything should eat the food and the poison, whether it's seeking it or not. And this one, you can see, died. So I made it kind of hard for them. And we might need to make it easier. But my hope is that there's actually a kind of optimal, and this one looks pretty good. There's an optimal one that it's going to, and it needs to really be able to see the food better. That's not optimal because it needs a bigger radius of food. Anyway, so let's add the evolution. It's time for evolution. Did I just really do that in my video? I guess I did. Okay, here we go. So, okay, first of all, if you've watched any of my other genetic algorithm videos, you will note that there is a process to a genetic algorithm in the traditional sense. That process is create the initial population, evaluate the population for fitness, apply crossover and mutation to create a new population. Now run it again. But if you watch through all of my videos towards the end, and I'll link to this also in the description, I discuss another way of thinking about an evolutionary system, which is a more continuous system, right? There is no fitness function. These agents, these elements, these creatures just have a random chance while they live to reproduce. So the longer they live, the more likely they are to reproduce. And so things that live longer, that gather more health and resources, will have more chances of reproducing, and hopefully over time, the things that aren't so great are going to die out because they won't have a chance to reproduce. So something that more mirrors the way that an evolutionary process might happen in the natural world. Okay, so let's add that. So the first thing that I need to do is I need to add a function, and I'm going to call it, I don't know if I should call it clone, because is that like a, that seems to be like some kind of JavaScript actual word. So I could call it copy, which is also some sort of keyword. I'm going to say clone me. I'm going to make a function called clone me. Oh, did it just not turn blue because I hadn't gotten rid of it yet? Okay, that's fine. I'm going to make the function called clone. And what that does is it returns a new vehicle at my location with my DNA. So the idea is that there's a function that creates a new vehicle, and it doesn't have to be at the same location, but that makes sense. The idea that suddenly I'm just going to copy myself, and by copying myself, I need to copy my DNA. So here's the thing. There's a lot of ways. One thing that you might think about is like, oh, maybe there's some scenario where there's two and they actually have to be next to each other, and then the DNA uses crossover to like combine the DNA to make a new vehicle. But I'm going to just do this simply by having just a copy, but that would be an interesting thing for you to try. And then maybe they have to evolve some kind of attraction force where in addition to eating the food and avoiding the poison, they also have to be attracted to each other so that they can manage to copy themselves. So, but I'm just going to write this function called clone. And what I'm going to do right now is I'm going to say for every single vehicle, and you know what I'm going to do? I'm going to say if random, I'm going to build this into the function. Maybe every frame they just have a 1% chance of returning a copy of themselves. Otherwise, I return nothing. Null. And a JavaScript function by default is going to return undefined probably. So I just want to say, I just want to do this like 1% of the time. So what I'm going to do here is I'm going to say var, I'm going to call it child or copy child. Maybe I'll just call it new vehicle equals vehicles index I dot clone. If new vehicle is not equal to null, then vehicles.push new vehicle. Funny, this evolutionary aspect is like the simplest part of this in a way. I mean, there's some more pieces of this I haven't done yet. So this idea of every so often, 1 out of 100 frames, if it lives for 100 frames, there's a good chance that at least one of those, it'll make a copy of itself. And then it will add that to the array. And luckily, I got it. Oh, this is a problem. Look at this. Vehicles. No, that's okay because I starts with that. So there really could be an issue where if I'm adding to an array while I'm iterating through it, it's never going to get to the end. But because I'm already going through backwards, I can add stuff to the end and just still go down to 0 and I'll be fine. So, okay, so I think I'm not going to get stuck in some infinite loop here. Let's now try running this. So we should see, let's make it really happen really often, just so we can see that there's these new vehicles 10% of the time. we should be overwhelmed, right? We're overwhelmed with stuff. So that's clearly absurd, and I'm going to crash the computer. So 1% of the time, it might be too often as well, but let's leave that for right now, 1% of the time. Kind of want to add a piece of food. Ooh, what happened there? Cannot, oh, so why, I think that happens, look at this. So it's possible right now for a vehicle to die and then clone itself. So I can put this just before I check for, or I could say like maybe it's about to die, it's not allowed to. Like I should let it like have one last shot. Let's let it have one last shot to clone itself. Okay, so as long as I clone before I delete it, we should be okay. Okay, so now you can see this stuff. Now, here's the thing. It's not actually copying its DNA. So I could write this function as much as I want. That's called clone. And I could pass in DNA to supposedly copy. But my constructor does not have an argument. So I need to add a third argument called DNA. And what I want to do is if DNA exists, is not undefined, I think that's okay. If it's just an, it'll be, any array is going to be defined, is going to return true, right? So, but maybe what I'll do just to be, no, that's fine. If DNA, I'm just going to say, if DNA is equal to undefined. So like if I didn't pass in that argument, then make the DNA randomly, right? This is what I should do. Otherwise, this .dna, now I don't want to say DNA. I could do this, but this is a bit of a problem because what I actually want to do, I might want to adjust. I might want to have like a little chance of mutation. So what I want to do is I want to say this .dna index. So no matter what, I always want to make it an array. And then I want to say this .dna, and I really should do this in a loop, but I'm not going to for a very silly reason in a second. So, and there's only 4 properties. So I'm going to just do these manually. Oh, this is terrible. I can't even look at this. I'm having a very, very weird feeling in my stomach, being very uncomfortable by writing this without a loop. But here we go. Now I should be copying the DNA. Oh boy. Boy, they really like to make copies of themselves. So I also think that this needs to be much less often. Let's make this much less often. Phone is ringing again. Okay, well, a bunch died out. That one looks like it's going to do pretty well. Copy yourself. Come on, get that food. Make a copy of yourself. Come on, you can do it. Make a copy of yourself. Maybe that's like 1 every 1,000 frames. That's way too little. I kind of want to get lucky and like have it make a copy of itself. But this one, look at this, optimal. Oh, there it did. Okay, so we can see it works. You can see that one that copies up. Now, it died immediately because they were both right there. And they like consumed themselves. So yeah, it's a little bit of an issue there. One thing that I think would be really helpful, I've done this with these kind of systems before, is to add this idea of if one dies, I'm going to create a piece of food right where it dies. So let's create a piece of food at x equals vehicles index I dot position dot x. So let's get the xy of that vehicle, and let's create a piece of food there. This is really going to help because that way if there's like a bunch, then like and a whole bunch die, there's a lot of food for the one that survives. So let's add that, and let's be hopeful that we get something good. Now here's the thing. One of the key principles of evolutionary systems is variation. And I'm really not getting that much variety to start with. So one thing that I might do, there's 2 things that I really need to add to this to have more variety. One is that let's make, how many vehicles do I make? I only make 10. So let's make 50 to start with. And you can see that's kind of too bad. And also, that reproduction amount was like way too little. So let's not make it 0.01, but let's make it 0.005. So there's a lot of them now, and so you can see like a whole bunch died all at once and left some food. So let's see kind of like who survives. So I'm going to let this run for a little bit and see how it goes. Now, it's really not, there's not a lot of food. So I don't know if I need to add, which is fine because they're really copying themselves a lot. So they're going to, this one's good. This one should be able to like kind of pick up a lot of food now, and then there's more food getting added. It's going to die. So anyway, so you can see here, there's a lot of stuff to tweak, and I've got to stop myself from tweaking and tweaking and tweaking. All right, so I have one last thing to add. One thing that doesn't happen, there is no mutation right now. And mutation is a key aspect of an evolutionary system, because what if the initial population doesn't have the right amount of variety, or enough variety, the optimal thing that we're searching for is not there in the initial population. So as these elements clone themselves, if they adjust their properties a little bit, we can introduce additional variation. Now there's a lot of ways I could do this. Number one is I could just randomly pick new weights, steering weights, and randomly pick new perception radii, if the plural of radius is radii. But what I'm going to do just to demonstrate, and I've done that, and that happens in some of my other videos. But in this one, what I'm going to demonstrate is like just adjusting those values a little bit, because I think that'll be interesting to see. So, and I'm going to do this in a kind of a very inefficient, silly way. And I can leave it as an exercise for you guys to write the code in a nicer way. But for example, I'm going to say, I could, I hate what I've done here. So one thing that would be better would be to have all of these have a normalized range. Like if all these values were always between 0 and 1, I could just tweak all of these randomly the same way. But because these have a different range than this, but I'm going to do this in a very long-winded way. And you guys can imagine, and I'll refactor this code another time in another video or just in a different example, or you can do this as your own exercise. But I'm going to say if random1 is less than, and let's make a global variable. I'm going to call it MR for mutation rate. And I'm going to say there's a 1% mutation rate, which is probably too low. But if random1 is less than the mutation rate, then this.DNA 0 adjusted by some tiny small amount between negative 0.1 and 0.1. Now I'm going to do that for this one, for the second weight, steering weight, and then I'm going to do the same thing for these last two things, but the range I might want to adjust it is between negative 10 and 10. Maybe I'm going to, and I probably should cap it so it can't go below 0, but whatever. Good enough for right now. So I'm going to, there's so many things about this that I don't like, but it's good enough for right now. I could rewrite this into a nice reusable function where I pass in the mutation rate and the amount of change. I'll leave that as an exercise for you. So this now randomly, they should be adjusted. Okay, here we go. Now let's run this. Let's see how it behaves. So we're just let this run for a little bit. We're going to do some deep breathing. I'm back from the past to the future, speaking in a falsetto. Everything died out. So this is the sad truth of this. As much as I have this idea of like, artificial general intelligence, and they're going to just sort of like learn how to do it, so much of this right now is a top-down design system, and getting this to behave in a way that's going to be interesting is really adjusting and fine-tuning that system. And I'm going to publish this code, and the things that I would like you to think about doing is you might be able to create a whole interface with sliders to adjust like the rate of how food is added, how poison is added, adjust the different ranges, adjust how much the health goes down. Let me try to at least get this to behave a little bit better. One thing I'm going to do is I'm going to add food at a much higher rate, which will make it easier. I'm going to have and also have the nutritional value of the food be a bit higher. And so I'm going to make that 0.3, and I'm going to actually make the poison really bad. 7.5. Okay, so I'm going to make the poison a little worse. And it's kind of bothering me how big those dots are, which is so unnecessary, but I'm going to draw them a little bit smaller. I don't know why, since like design is clearly not my forte, but let's let this run. And also I could add something where I could click the mouse and add new vehicles, But let's see what we get over time here. So there should be a lot of food. You can see, there's some element of balance here. If there's too many good things, they're going to eat all the food. But you can see what's left, right? There's a bunch. Let me travel to the future again. I'm back. Let's add one more feature where I can say, just in the main sketch, I'm going to say, where are the vehicles? Here. I'm going to add the mouse dragged function. And I'm going to make it so that whenever I drag the mouse, I'm adding new vehicles at mouse X and mouse Y. So I can run the sketch and vehicles, I just say vehicles.push. Okay. So I'm going to let this run for a bit. Hello from the future. So I made some tweaks to various variables in the thing, like how much does the health increase? And you can see now something rather optimal has kind of appeared, which is what I had suspected all along and said, which is that you can see here's a whole bunch of vehicles with a strong attraction to food, not being so attracted, a strong repulsion to poison, and being able to see food much farther than being able to see poison. You can see this is just propagated, and they're just kind of eating up all the food. Now at some point, a bunch of those are going to die out, but when they die, they add more food. So I think we have arrived. Now, here's the thing, a lot of stuff that I didn't do. One thing is this would be much nicer to look at. And I'm going to, if I just made a little checkbox that I could check here, and then I don't see the debugging information, because I really don't, watching the debugging information is just for me to have a sense of what's going on. And I can barely understand where the food is and what the vehicles are doing. So it would be nicer to look at it. Maybe I'll add that after this video is over and have it as part of the code. Then, of course, there's all sorts of interesting possibilities here. What are other things you could add to the system? Somebody suggested having the probability of reproduction be related to actually their health value, so that if they're really healthy, they're more likely to reproduce than if they're like close to having a health of 0. So I'm sure you have lots of creative ideas. Add an interface to play with different parameters, design it in a different way, make this into a game somehow. Somebody suggested allow the user to save them by adding food. So there's all sorts of possibilities here. So I hope you enjoyed this really long 4-part coding challenge. I hope that you make something creative with this evolutionary system, expand on it. I would love to share results of things that you guys make in future live streams or videos. And so thanks for watching. Stay in touch, leave a comment. I'll be back, more videos soon. Okay, goodbye.